This tiny organism is about to encounter something it's never experienced before, and it's only Thursday night. You've probably heard this before. Clear liquor gives you less of a hangover, and if you spend more money, guess what? You're getting a cleaner drink. But is there actually anything behind those claims, or are they just myths we've all accepted? Today we're putting Tito's Vodka, Bacardi Superior, and Captain Morgan Spiced Rum under the microscope. First, we'll see what each one actually looks like. Then, we'll let the alcohol evaporate to find out what each liquor leaves behind. And finally, we'll introduce live rotifers to each sample and watch how they react. By the end of this video, you'll know which liquor looked the cleanest under the microscope, which one left behind the most residue, and whether these common beliefs have any visible evidence behind them. Let's go. I had no idea what to expect, so the first thing I did was put each liquor under the microscope. So I started with Tito's first. Let's take a look. So at this point, there still wasn't much to see, so I changed my approach a little bit. By adding a drop of methylene blue, I can increase the contrast and hopefully reveal any residue that was too difficult to see before. So here we are, 100 times for Tito's, and if you look around, honestly, this is exactly what I'd expect from vodka. It's distilled several times. There's just not much left for the microscope to pick up. The tiny blue specks and those thin hair-like strands are most likely a mix of residue left behind after the alcohol evaporated and a few artifacts from preparing the slide. So when I'm looking at a sample like this, I'm not focused on one little particle. I'm looking at the overall picture to see how much material is actually there. So vodka is about as clean as it gets. So I'm really not surprised there's not much here, but this long strand isn't likely from the liquor, you guys. It's probably just a tiny fiber that found its way onto the slide. That's actually pretty common when you're working under a microscope. So at 400 times, something you can't even see with your eyes suddenly looks like a giant rope. It's crazy. So let's move on to sample B. Okay, so here's Captain Morgan, sample B. It looks different. Instead of the mostly empty field we saw with Tito's, there were noticeably more stained particles scattered across the slide. That makes sense because spiced rum contains additional ingredients like caramel coloring and flavoring compounds that simply aren't found in a typical vodka. So at 100 times, those tiny particles become much easier to see. Now remember, we're not looking at alcohol molecules. Those are far too small for a light microscope. What we're seeing is residue that remained after the alcohol evaporated, along with anything the methylene blue was able to bind to. Compared to Tito's, there's clearly more material left behind. At 400 times, as we zoom in, you can start seeing larger pieces of residue mixed in with the smaller particles. I can't say exactly what every structure is just from looking through the microscope, but this is exactly why comparing the overall pattern is more useful than focusing on one object. Captain Morgan's leaves behind a much busier field than the vodka did. So we're at 1,000 times, and the larger residue becomes even more obvious. What's crazy, it's not the shape itself, it's the fact that Captain Morgan's leaves enough material behind for us to study at this magnification. That's a big contrast from Tito's, where there was very little visible residue after evaporation. So let's move on to sample C, which is Bacardi Superior. And don't worry, folks, the rotifers are coming after this. All right, so here's Bacardi, and it looked a little different right away, but not because of the rum itself. What you're seeing here is the stain collecting as the sample dried. So as liquid evaporates, it can pull dissolved material toward the edges. It creates a pattern like this. And it's a good reminder that under a microscope, how you prepare the sample can just be as important as the sample itself. So 100 times, the stain pattern becomes even more obvious. And this is why I don't focus on one shape or one spot on the slide. Instead, I'm looking at the entire sample to see how much residue is actually left behind. And that's where the real comparison begins. So what do you guys think about the three under the microscope, sample A, sample B, or sample C? But let's move over to the rotifers and see how they react. This is pretty cool. Okay, Tito's rotifer test at 100 times, and I'm going to introduce the Tito's on the right side of the screen. And it's gonna move from right to left. So you guys watch this wave, and it's pretty cool. You see how he's using his cilia to create the vortex to suck things in so he can eat it? That's pretty awesome. So here comes wave, and just watch his reaction. So here comes a tsunami right there. That's a full shot of Tito's vodka. So watch his reaction. Looks like he's still foraging, he's still eating at this time. He pops his head back in. And the #1 defense for rotifers is to go into a ball. So if he goes into a ball and stays that way, something's wrong. Something's wrong with his environment. Others will just, crawl around for a while, look at things, trying to relocate. But if they're really in danger, they're going to hide and curl up in a ball like a turtle. So let's watch what he does. So after a while, I've been on this guy for 10 minutes and he took it like a champ. He's still crawling around or swimming around, and he's still foraging and he's still eating. So that vodka shot had no impact whatsoever. Look at him right there, he's feeding. So this guy is Captain America, man. He took it. Either this dude's a raging alcoholic or he got lucky. All right, let's move on to sample B, which is Captain Morgan's. Let's see how that guy holds out. All right, we'll call this guy Captain Morgan's rotifer test. He's at 100 times, and this is good timing. He's actually eating, foraging. He's eating algae, microscopic debris, all that stuff. So I'm gonna introduce the Captain Morgan's on the right side of the screen. It's gonna move right to left. So watch this tsunami come, and let's see how he handles it. Okay guys, here it comes, watch it. It looks like a wave right there, do you see it? Okay, it just passed him. And looks like he's doing okay so far. Let me center him a little bit right here so we can get a view. You can see debris pass him, and so far, so good. He's still eating. Okay, he's starting to move around a little bit. Maybe it's affecting him, I don't know, but he seems confused. He knows his environment just changed. He doesn't like what he's engulfing. He's no longer foraging, he's no longer eating, he's looking for a place to go. So this is a bad sign for him. He's trying to protect himself. And like I said, he'll go into a ball if he feels threatened, or that's how he protects himself. And these guys have been around for millions and millions of years. And this is how they've survived for this many years. Okay, so I sped it up. About 20 minutes has passed. And so finally he come to a rest here. He's still moving, but he's in a ball, like a semi-ball. And this is where he remained for roughly an hour and a half, and he did not move. So this is weird for Captain Morgan's. I'm not sure why he's acting this way. Maybe because he got 2,000 gallons of liquor poured on top of him. I think I'd act the same way. But what happened with sample A, which was Tito's, he took it like a champ. But this guy, he's not. So he's done. Anyways, let's move on to Bacardi and see how he fares. Okay, here he is. He's eating, which is good timing again. This is Bacardi Superior, and it's gonna hit him from the right to the left. And did you guys see that? There he is, and he's still eating. Good sign for Bacardi. Let's see how well he does. You see the vortex, he's still eating, and he knows obviously something has changed, and but he hasn't moved around much. He's still sucking in debris, and that's a good sign. So check this out, I blew him up to 400 times so you can see his head and how the cilia works. It's pretty cool, and he's pretty active. Okay, so you know what, I'm gonna hit him again. So from right to left, you guys see it coming in? And there it is. And let's see how he fares, because that's a lot of Bacardi. I'd be passed out by now, but this guy is a champ. He's still at it, and I like this guy. So I blew it up to 400 times so you guys can see him. It's hard to track him because he's so quick and he's active. I don't know if he's drunk or if the Bacardi got him going, but so here you go. And the whole time, I mean, 30 minutes, he did well. He wasn't affected. It kind of sped him up. So there you go. You have Captain Morgan Spiced Rum, you got Titos, and you got Bacardi. Going into the experiment, I expected to see obvious differences right away. Instead, all three liquors looked the same under the microscope. It wasn't until the alcohol evaporated and I added methylene blue that each one started leaving behind its own microscopic fingerprint. Tito's left behind the least visible residue, Bacardi landed somewhere in the middle, and Captain Morgan's left behind the most. As far as the rotifers, their reactions were fascinating to watch, but they don't tell us how alcohol affects the human body. They simply show us how a microscopic organism responds when it's directly exposed. This wasn't about proving one liquor is healthier than another. It was about looking beyond the label and seeing something our eyes normally can't. Please subscribe and check out this video to see if rotifers like McDonald's hamburgers. Take care of yourself and others.